number 100 billion, 100 billion, rounded of course. If you take those hamburgers, lay them end to end, start right here in Nashville, end to end, you can ask how long, how far will it go? You can ask. All right? So will it reach California if you go due west? Yes, it will. Will you cross the Pacific? Yes, it will. Cross Asia, back around the backside, come around the Atlantic, come back here? Yes, it will. And you can do that 52 times. Okay, now, you have leftover hamburgers. After you went around the earth 52 times, now you're going to stack them because you're bored going around the earth. So how high a stack can you make with what's left over after you went around the earth 52 times? You can make a stack so high it will reach the moon and back. Then you would have exhausted your 100 billion hamburgers. And this is terrifying news to cows. Cows can't relate to that. So 100 billion is a huge number. You go up a factor of 1,000 on a billion, you get to a trillion. So now sort of disk drives are terabyte size. Okay, that's where you get that. Trillion, 10 to the 12th power. That's about how many seconds have passed since Australopithecus. Oh, by the way, a billion, I don't know if you knew this. Let's go back. Past McDonald's. I celebrated my billionth second in life. It happens when you're 31, in your 31st year. Anyone here 31 years old? That'll be a few people. Okay, this year you will turn a billion seconds. And so I had a little bit tiny champagne bottle, right? And when that billionth second happened, it was awesome, right? And I'm going to try to create an app that's on my website. We can type in your birth time, and then it'll tell you when to get your billionth second. It's not a trivial calculation because you have to add in the leap seconds, and they're added erratically, so you got to do it right because you're counting seconds here. So it's a billion seconds. So if you wanted to count to a billion, and you did one number per second, it would take you 31 years. So that would mean then that if you were going to count to a trillion, which is 1,000 times bigger than a billion, how long will it take you to count to it? 31,000 years. You cannot count to this number in your lifetime. Just don't try it, all right? Let's go up by another factor of 1,000. We got billion, trillion, quadrillion. There you go. Prefix peta, 10 to the 15th power, 1 with 15 zeros. I did the calculation. About 100 quadrillion is the estimated number of sounds and words ever uttered by all humans who have ever lived. That's how big this number is. It includes all the noises made by babies, all the filibusters in Congress, all the people who you think talk too much is in that number. Quadrillion. 10 to the 15th power. Let's go up by another factor of 1,000. Now 1,000 times bigger than that. And you get about the number of grains of sand on an average beach. Sand. I don't know the last time you've been on a beach. There's a lot of sand on a beach. All right? And you get this is all the sand that comes home like in your crotch in the bathing suit. Take that out, count that too. I got that in this number. All right? I got that covered. That's 1,000 times bigger than a quadrillion, 1,000 times bigger than a trillion, 1,000 times bigger than a billion. Go up by another factor of 1,000, we get sextillion, 1 with 21 zeros. That is the number of stars in the observable universe. It exceeds by far all the other numbers I just presented to you. And that's just the observable universe. And so when people say, oh, we're this, and Earth is special, and Earth is this, excuse me? The universe is big. The universe is bad for your ego. Let's find out why. Well, let's take a look. There's a time where we imagined that sort of Earth was the center of all the universe. That's just human hubris kicking in. All right? We are the center. Well, it kind of looks that way, right? You look up at the night sky, everything goes around you. And there's no urge to try to show that that was not the case, because it just felt so good to be in the center of everything. Who's going to want to disprove that? Come to find out, Earth is one of many objects in orbit around the sun. Well, surely the solar system is special. Maybe that's in the center of the galaxy. No. The solar system is out in the suburbs, 2/3 of the way out from the center of the Milky Way galaxy, in a completely undistinguished spiral arm of the system. Maybe the galaxy is special. The Milky Way. Maybe that is the universe. That's what was presumed up until the 1920s. Up until 1926. The galaxy, the Milky Way, was our understanding of the extent of the known universe. And then Hubble, not the hardware, but the human, Edwin Hubble, after whom the hardware was named, discovered that there are fuzzy objects on the night sky that are entire other galaxies, separate from our island universes, if you will. We got 100 billion stars, they got 100 billion stars. The universe is the sum of galaxies, not simply the stars that you can count on the night sky. Well, wait a minute. Is there just one universe? We've been down this road before. We're thinking Earth is special and it's alone. No. So, no. Yeah. No. And then we say universe? Philosophically, there's no reason to stop here. In fact, there's good cogent reasons for thinking that our universe is one of many comprising the multiverse. Now, just to disturb your slumber this evening, I will alert you that the trend here is whatever is the unit, it is not unique in the universe. There's more of them. So that leaves you thinking, if we are part of a multiverse, then what is the system that is itself comprised of multiverses? Who knows where this ends? Right now, we're between the universe and the multiverse. And 500 years ago, we were between the Earth and the solar system. It marches on. And where's Earth in this? We are reduced to obscurity as the universe demonstrates that it's bad for our ego. It won't let me go to the next. There we go. It should work. Found it? Yeah, pissed off. Did we get it yet? There we go. So, just an early concept. This is before science really existed as a way of deducing the nature of the universe through experiment. And so there you have Earth looking really big, bigger than the sun. And that's just embarrassing, right? Because, just look at how that's drawn. Just look at that. Now, here is an image of the sun, and here is a close-up on one of these spots on the sun, which are officially called sunspots. sunspots. Are there any geology majors here, or chemistry majors, or biology majors? Okay, you're all like going whoop-de-whoop. However, we see a spot on the sun, we call them sunspots. You see some simple rock or some simple molecule, and out comes all the Latin. I don't know what the hell you guys are saying to each other. Oh, it's a pretty rock. Oh, that's orthoclave feldspar. It's like, most important molecule in the human body, deoxyribonucleic acid. 9 syllables later, maybe you're done with the word. In the universe, the beginning of space, time, energy, and everything, Big Bang. Big red star, red giant. Region of space, light doesn't come out, you fall in, you don't come out, black hole. We are one-syllable simple people. And all my colleagues in the other sciences go out of their way to put the complicated word on what they're describing. So in the universe, we just call it like it is, like we see it. Because the universe itself is complicated enough. We don't need complex vocabulary to create the smoke screen where you would trip on the smoke screen before you even get to the ideas. Maybe that's why our stuff makes headlines when we discover things in the universe. Maybe that's why Hubble telescope images don't even require a caption for you to embrace their beauty and majesty. Think of that. We don't need no stinking captions. A sunspot magnified from the center. And well, how big is that sunspot? Oh, that's about how big it is. Earth is littler than the sun's acne. Okay? Talk about your ego. One more. All right? You want more ego-reducing facts? All right. Here's one of my favorite images of the planet Saturn. My favorite planet after Earth. Now, what's different about this, it looks a little different because in this image, Saturn is eclipsing the sun. The sun is behind Saturn, and the sunlight is beaming up through, and you can see the refracted light on the edge of the sphere. That's the light coming through the upper limb of the atmosphere, and the rings are lit from below. We're looking towards the inner solar system where the inner planets orbit, Mercury, Venus, Earth, and Mars. This is the spacecraft Cassini, still there in orbit around Saturn. Still there. But if I zoom in, have this a little louder. Okay. Thanks. All right, so wait, I see something there. Wait, what is that? I see something. What is that? Oh, that's Earth! Oh! Earth! All 7 pixels. Get over it. It's called the cosmic perspective. Now here's somebody who didn't get over it. So 12 years ago, we opened the new planetarium as part of the Rose Center for Thank you. 2 people have visited. The rest of you all invited, just come, and you say that you attended my lecture, and they'll still charge you to get in. But that initial show, we started on Earth and we zoomed out to the outer edges of the universe, and Earth shrinks to nothingness, and then the sun shrinks down. You can't even see the sun in the star field, and then the galaxy shrinks down. You go to the edge of the universe and back. Within a couple of weeks of opening, I got this letter from a professor of cultural psychology at University of Pennsylvania. He said, I'm writing to discuss the possibility of conducting a research project in collaboration with the Hayden Planetarium. My research focuses on the psychological experiences associated with feelings of insignificance. And I'm thinking, bummer of a job, man. What's that like? He's coming home. Honey, I'm home. How was your day at work, at the office? How does that go? And so he said, I'd be very grateful if we can conduct a simple questionnaire at the planetarium. But what do they want to do? I recently saw the space show, and needless to say, it was the most dramatic elicitor of feelings of smallness and insignificance that I've yet encountered. I'd be grateful we can conduct a simple questionnaire. I think they want to interview people going in, all smiley, and they're expecting that they come out deeply depressed. And I submit to you that if that actually happens, then maybe you entered the room with an unjustifiably high ego to begin with. You think you're special in the universe. You think you're in some privileged place. Of course you'll walk out depressed. But if you have an accurate view of the universe, where we are a participant in this great cosmic unfolding of events, you can't possibly walk out of there depressed. The universe becomes an uplifting force, the likes of which you have never seen. More on that later. The universe is like a time machine. A time machine. So, it takes a telescope. This helps out. That's, of course, the Hubble telescope in orbit around Earth. It's still up there, still getting data. And so when you take a telescope and you look out into the universe, you see things at different distances. So this is taken from the moon. It's Earthrise from the moon. By the way, on the moon, Earth doesn't rise. It's always just in the sky, or it's not. Okay? So that photo, Earthrise, from the Apollo era, it's called Earthrise. They're lying. The Earth only rose because they were in orbit around the moon. And so being in orbit enabled the Earth to rise. When you look at that and you think Earth is rising on the moon the way the moon rises on Earth. No. So here we are. So the moon is 1.3 light seconds away from Earth. We see the moon not as it is, but as it once was, nearly 1.5 seconds ago. And how about the sun with its spots? If you took the sun and plucked it out from the center of the solar system, we wouldn't know about it for 8 minutes and 20 seconds. We'd still feel the heat and the light and the warmth, and we still orbit this spot where some monster had just pulled the sun out from the middle. 8 minutes and 20 seconds later, we fly off at a tangent to interstellar space and plunge into a deathly cold, and we all freeze to death. Okay? Have a nice day. Yeah. So the sun is 8 minutes and 20 light seconds away from us. So we are already looking farther back in time, although not significantly so. What's 8 minutes in the history of the sun? This star, this is probably the most people who have ever laid eyes upon this star in the history of images. This star is LHS 2520. It is 27 light years away. It did not have meaning until last week. because this star is what I handed to DC Comics. And they have assigned this star to be Superman's home star system, around which Krypton orbits. Now, why this star? Because Superman is in his late 20s. He's about 27 years old. We've made it so that he got here on a wormhole. Remember, he was launched as an infant, Moses style, and he's in a basket, right? Cast not on a river, but into space. He's an infant when he's launched. He's an infant when he lands. That little baby went through a wormhole, got here ahead of the light beam from his home planet. He visits the Hayden Planetarium. And I help him, Superman that is, and I help him find this star, and he uses his superpower vision with the telescopes, and he sees the destruction of Krypton. It's sad. That's last week's Superman comic. Looking back in time at this star. There it is. Last week this happened. So the funny thing I said, you know, if it makes no difference to you guys, in one way or another, you think you could like take a few pounds off my midsection? You know, if it makes no difference. They said, these are the comics where everybody looks good. That was, so I come walking out. That vest is real, and I'm wearing it now. So I got so many comments on that. They said, "Great vest! You know, did they invent that for the comic?" No, they drew a real vest that actually existed. So they were all looking concerned. So we look back in time, 27 light years, 27 years back. This is 7,000 light years away. We see stars being born, not as they are now, but as they were 7,000 years ago. This is the center of the Milky Way galaxy, 35,000 light years away. The nearest large galaxy to our own, Andromeda, 2 million light years away. The light we see from that galaxy left that galaxy before we were human on this earth. We are looking back in time. Here's one of my favorite galaxies for just that purpose. Messier 100, that's the ID for it. And it is 65 million light years away. If you're on that galaxy looking back to Earth, what do you see? You see the dinosaurs going extinct. You see an asteroid coming in, and one galaxy saying to the other, one dinosaur saying to the other, now is the time to have a space program. A little too late. Actually, that was a Gary Larson comic. Two dinosaurs arguing about whether they should have a space program. No, we have other concerns on Earth. This is the farthest map of any visible object in the universe, the famous cosmic microwave background. This is the birth image of the universe. This is what the universe looked like. It's color-coded because it doesn't make sense otherwise. What the universe looked like about 300,000 years after it was born. So almost all of 13.7 billion years ago. So as we look out in space, we look back in time. There would be no knowledge or understanding of cosmology without that fact. In other words, if light traveled infinitely fast, we would see everything in the now, and there'd be no record of the past. The fact that it takes light time to reach us lays bare the entire history of the cosmos. And that has empowered us to deduce the nature of the universe. The universe is a time machine. 7. Well, I said the universe has a lot of stars in it, but now I'm going to tell you that the universe is big. The universe is big, and molecules are small. Now, this sounds like completely stupid obvious, but I want to really drive it home how small molecules are. Okay? All right. Let's take a look at, water is comprised of water molecules, and the water molecules what? H2O, of course. You ever hear that geeky water molecule joke? Oh, you have? Somebody said yes. It's the one where you go to the bar, and, okay, so you walk into, two people walk into a bar, and I say, I'd like a glass of H2O. And then the person serves me. And the person next to me, who I walked into the bar, says, I'd like some H2O too. They get served, they drink it, and they spit it out. Because they just got served hydrogen peroxide, H2O2. It's a geeky joke. That'd be a little chemistry fluent there. Because if you're not part of the solution, you're part of the precipitate. Okay? How small are these molecules? Well, here's a list of people. 7 famous people. You might ask why they all made it onto the same slide. Some of you will know why. Most excellently, you'll know why. Bill and Ted rounded these guys up in a phone booth and brought them to Encino, California. Oh, sorry, I said San Dimas. I'm confusing it with the frozen caveman who came out of a melted glacier. That was, okay, San Dimas, California. So here's what's interesting about this set of people. I think I put them in roughly time order. There are more molecules of air in a breath of air than there are breaths of air in the entire atmosphere. There are more molecules of water in a cup of water than there are cups of water in all the world's oceans and seas. So what that means is, if you drink a cup of water, you're pretty much guaranteed it contains molecules that pass through the kidneys of Genghis Khan. The air you breathe is air that surely went through the lungs of Abe Lincoln. Think about it. I drink a cup of water. It comes out of me one way or another, eventually. All of those molecules. And there are more molecules in that cup of water than there are cups of water in the whole world. So given enough time, not even that much time, the molecules that came through my kidneys scattered everywhere in the world, with plenty of molecules to land in everybody's cup, no matter where they draw it from around the world. Someone just said, ew. You just got to ew now? I mean, there was some ew-worthy things before that moment that I said. So, in fact, if you do the math, there's something like 10 to 100,000 molecules, enough per cup of all the cups of water in the world that would have come through your kidney and got put back out into the system. So you share in the breath and in the pee of all these people on the list. You could have put Jesus here, doesn't matter. You drinking water went through that man's kidneys. I could put it, but Bill and Ted didn't go get him, right? Just these 7. So, to have you appreciate how small molecules are, it is a certainty how much we have all shared each other's fluids. Now say you. 6. The earth wants to kill you. I'm sorry. Every time someone says, oh, earth is a haven for life, oh, look how beautiful. Well, you know why you're saying that? Because you found the spot that doesn't happen to be killing you at that moment. And you moved into that spot. And if it's a little too cold, then you make clothes. If it's a little too hot, you put in air conditioning. And then you say, oh, earth is beautiful for me. Right here. It's just fine. I love earth. You know, earthquakes, volcanoes, tsunamis, hurricanes, tornadoes, drought, floods, disease, pestilence. If you look at the death toll exacted by nature through these means on the human species, it is staggering. And it continues. It continues. Sandy was one of these systems. Except the death toll for Sandy doesn't come close to the death toll that other hurricanes have brought. Because Sandy was actually only Category 1. And most of the people affected by it, it was tropical storm winds, including like my neighborhood. Tropical storm winds and not hurricane winds. So Sandy was mild in terms of death tolls. But just look up those numbers and it is staggering. This is Earth wanting to kill you. And not only that, the universe wants to kill you too. And the universe is really good at it. Because it does stuff like this. This is a hole in the ground in Arizona. Arizona is famous for holes in the ground. This is one of them. What's the other one? The Grand Canyon, of course. When I was 14, I visited both the Grand Canyon and this meteor crater on the same trip. So I looked at the Grand Canyon. Not bad. What a Grand Canyon this is. Okay? Finally, the geologist got something right, okay? A Grand Canyon. Okay. So I'm cool with that. Okay? I forgot how long, the 10 million years, whatever the number it took to carve this thing. The surrounding terrain rises and the water level keeps at it, and so it cuts away at the ground. So you have a nice cut through the side. You see the sedimentary rock all throughout the side. Well, fine, I'm giving it its props. I got no issue with the Grand Canyon. But then I visited this thing. This is a crater nearly a mile in diameter, deep enough to sink a 60-story building. This was made in 1/10 of a second. And I said, awesome. Ooh, that's my favorite kind of hole in the ground. Clearly an asteroid did that, and not a very big one at that. All right? There are asteroids out there. There's a killer asteroid called Apophis. Apophis, named for the Egyptian god of death and darkness. Apophis is headed towards Earth. Is everybody worried about, 2012? It's like you have no clue what you should be worried about. Apophis is actually headed towards Earth. It's going to have a close approach on April 13th in the year 2029, which is a Friday, by the way. Just in the interest of disclosure, that's a Friday. We can do models. If it hits at all, it's most likely going to hit in the Pacific Ocean, 500 kilometers west of Santa Monica. Why did I say oh? You guys are far away from the Pacific Ocean here. This is Tennessee, last I looked. What are you worried about? You'll be just fine when this hits, okay? So you can simulate what this will look like. And the official name of Apophis is 2004 MN4, in case you wanted like the phone number of it. That's it. Okay. Now I think I can get this to do the simulation. Let's see. Can I connected the simulation to it? Do it. It's not this. I swear I did. Yeah, no, I can't get it. So I have to pantomime what it does. Okay. So in the simulation, the impact is in the Pacific, and you can see a tsunami work its way to the entire west coast of the United States and Hawaii, and it goes all the way to the Aleutian Islands and over to Japan. All right? Tall, so about the height of a 5-story building, and it'll ablate cleanly the entire west coast of North America. And you get that because the asteroid plunges into the Pacific, and then it explodes at a depth of about 3 miles, cavitating the Pacific. And so the first impact sends the first tsunami wave. But now there's the matter of that hole in the Pacific. What do you do about that? Well, if you're a wall of water 3 miles high, 3 miles across, what's the first thing that comes to your mind? You fall into the hole, right? If you're a wall of water, this is what you do, right? So you fall back into the hole, it will slosh into itself, rise up to nearly stratospheric heights, fall back to the ocean, create another tsunami wave. And this movement will create a rhythm of tsunamis separated by about 45 seconds each, and it'll do it for upwards of a half an hour. So what happens is the first tsunami comes in, but there's another one that needs that water to come in right behind it. So the first tsunami comes in, but it only can get so far because it gets sucked out by the next tsunami. All right? So you know how far that is? It's about a quarter mile. So you could set up like a velvet rope along the coastline and have everybody come up to that and just watch the whole thing unfold. Sell popcorn. Nobody has to die. 2 people will die. 2. The stupid weatherman who said, get a little closer, you can see the surf coming up. Dead man number 1. Dead man number 2. I'm going to surf that. Okay? Let's surf, yeah. Dead person, 2 dead people. That's it. 2 dead people. The surfer and the weatherman. So what happens is the water comes in, it goes back out to sea, carrying with it all of the $1 million homes along Malibu and the rest of the coastline, and then it brings all those homes back in slightly different shape than they were when they first went out. So this is an ablative churning of all the populated structures that occupy the west coast of North America. So if it hits, it would do $1 trillion worth of damage. We have a way to make this not happen. This is a gravitational tractor beam. If I'm Apophis, and this is that gravitational tractor, so what you do, you launch it, and you park it next to Apophis. All right? Now, we're going to feel each other's gravity. That's how that goes in space. Okay? So we're going to want to fall towards each other. However, you put on retro rockets on the spaceship, and you prevent that from happening. So it wants to fall in, and you sort of prevent that. The act of firing these rockets, preventing us from coming close to each other, has the effect of towing me out of harm's way. You don't have to destroy it, you just have to make sure it doesn't hit Earth. Now, we got the generals who are ready to blow the sucker out of the sky. We got those, because we got the silos, we could do that. Here's the problem. In America, we're really good at blowing stuff up. We're less good at knowing where the pieces end up. At the end, you don't want to blow this up, and they have 2 pieces headed towards Earth. One towards Tennessee and one towards Malibu. So the kinder, gentler solution would be to deflect it out of harm's way, except, of course, there is no funded program to do that. Now, by the way, this asteroid is about the size of the Rose Bowl. It would wreak havoc on the west coast of the United States, but it wouldn't render us extinct. Oh, no. Well, for that, you need a bigger impact. You need killer asteroids. And there's the Permian-Triassic extinction period. We don't think that was an asteroid, but we don't know what it was. So the jury's still out on that one. And this is the famous KT extinction that took out all the monstrous dinosaurs. That one, that would have looked something like this. See, that's a bad day on Earth right there. Now, you don't want to be there. All right? Here's another view. You got the pterodactyl checking it out. And I once showed this picture in a high school class, and someone in the front row, because high school, if you're in the front row, is because you're smart, right? Back row people, those are the ones who sleep. So front row person raised his hand and said, "Is that an actual photograph?" Well, yes, the pterodactyl had a digital camera, and we extracted the SIM disk out of the camera. By virtue of these asteroids, estimates are something like 95, 96% of all species of life there ever was are now extinct. That is not the signature of a planet that embraces life. That's what a planet does when it's doing all it can to kill you. That's Earth. Now, of course, I'd rather live on Earth than on Venus, where you would vaporize in 20 seconds, okay? So, all things considered, I'd rather be on Earth. But don't run around and say that Earth is nice to us, because it is so not. Earth might not be the origin of life. It's hard to assess what the likelihood of this is, but it's certainly plausible. There's something called panspermia. Panspermia. So here's how it works. If you do the models of the formation of the solar system, all evidence shows that Mars had running water before Earth did. Right? So put a little check in that box. Earth, running water before Earth. 2, early solar system, there was a lot of impacts, leftovers from the formation of planets, still accreting to make the planets themselves. We have learned from computer models that if you have a strong enough impact, it can fling surrounding rocks into interplanetary space. It can fling them. One way to try that is you can sprinkle Cheerios on the bed. And then take your hand and slap it in the middle of the bed. Cheerios will go upwards, achieving escape velocity from the bed. Okay? This is a similar sort of wave flinging phenomenon. Now, on Earth, we have found branches of the tree of life, microbes, that thrive under conditions that would kill us. Kill us. We call them extremophiles. Some of them can be freeze-dried and reconstituted later. Some of them survive very high sort of radiation. I mean, they're hardy, okay? You suspended animation, high pressure, low pressure, high temperature, low temperature. These are conditions under which certain branches of bacteria thrive. You could, like I said, you could freeze dry them, high radiation, high acid. That's on Earth. If such bacteria started on Mars and got caught in the nook or the cranny of a rock that got flung into space, then that rock would move through space and later on land on Earth, seeding Earth with microbes whose point of origin was Mars. We did the calculation. There's several tons of Mars rocks here on Earth, not yet collected from the meteorite supplies. All right? So you can calculate how much stuff is moving from planet to planet. Get a stowaway microbe. We may be descendants of Martians. Some people perhaps more so than others, and evidence may point to. Now, there's a photo that I just got from NASA. You know, we have a new rover there. This is still classified, actually. I smuggled this out from the NASA headquarters. So this is the very first picture taken by the rover from Mars, right there. It's classified. Doesn't leave this room. $99 billion in one. Right? We're all Martians. Well, what about life? You know the number one molecule in the human body? Someone said hydrogen.
Water.
Water, thank you. Who said hydrogen? Who said hydrogen? Stand up. Who said it? Let yourself be known. Hydrogen, a pure element. We'll get to the elements in a minute. The number one molecule in the human body is water. We're like 60% water, something like that. Now, in terms of the atoms that are in us, hydrogen is very high on that list. But we never say that we're hydrogen-based life. We are, in fact, carbon-based life. Carbon. Carbon is the foundation of life as we know it. Why? Carbon is the stickiest element on the entire periodic table. It combines with elements every which way. I once interviewed Jon Stewart for my radio show, Star Talk Radio, and that's when I learned he majored in chemistry when he was in college. Did you know that? Then he switched to psychology later on. So I asked him the geeky question, did you have a favorite element? He said, yep. I said, what was it? He said, carbon. Now, I know why carbon is like my favorite, but I want to get his reason why it's his favorite. I said, why is carbon your favorite element? He said, because it's the slut of the periodic table. It combines every way you want it. So that was like comedically deep, right? I mean, he had insight into carbon. You can make more molecules with carbon than you can other kinds of molecules that don't have carbon combined. In other words, make a list of all possible molecules without carbon. You can make more molecules with carbon than that list. So, if there is a chemistry on which you want to base the diversity of life, and you're picking elements off the periodic table, carbon is your element. Carbon. Not only that, carbon is plentiful. It is plentiful. Forcing you to ask, would carbon be the foundation of life as we don't know it? It doesn't have to be. There's many science fiction episodes that talk about silicon-based life. That's another element that forms in a lot of the same forms molecules in a lot of the same way carbon does. You don't need to appeal to silicon because there's 5 times as much carbon in the universe as silicon. Plus, silicon makes bonds that are very hard to break. Silicon is like the active ingredient in rocks. We are carbon-based life. Well, what does that mean? Let's look at the abundance of elements in the universe. You can rank them. Let's rank them. The universe itself. Number 1 atom in the universe, hydrogen. Number 2 atom in the universe, helium. Number 3, oxygen. 4, carbon. 5, nitrogen. And my favorite element of them all, other. Okay. Now, how about life on Earth? Life on Earth. Let's find out. Number 1 element in life on Earth, hydrogen. Number 2, well, is it going to be helium? No, it's not going to be helium. Why? Yeah, helium doesn't react. It's inert. It's on the right-hand column of the periodic table. All of those elements are called what, remember? The noble gases. Do you know why they're called noble gases? I'm going to tell you, the Brits. Now watch. Here's what happened. The British, who discovered most of those elements on the right-hand side of the periodic table, noticed that these elements do not commingle with any others. And who in British culture do not commingle with anyone else? It's the noble class. So their asinine caste system ended up in our periodic table of elements, reminding me why we fought a war to get the hell out of there. Excuse my language. And we're stuck with it. The noble gases. What they didn't know is the noble gases don't even combine with each other. All right, they missed that part in their labeling of it. So helium, you can't do it. Helium, you can't. You could breathe it and sound like Mickey Mouse. That's about it. That's all you can do with helium. So no, it is not next. It's not. Okay? Well, you know what is next? Oxygen. And the hydrogen and oxygen give us what in our body? Water. There you go. Next to the human body, carbon. Next, nitrogen. Next, other. Thank you. So, we are one for one, the ingredients of the universe. If we were made of some exotic elements, like an isotope of bismuth, then you'd have an argument. You could say life on Earth is rare. It's got to be unique because the ingredients are so unusual. It's like 1 in a zillion that you could put these ingredients together that way because they hardly exist in the universe. We're made of the most common stuff there is. So when you think about aliens, there's not a reason to think that they're made of something else. There just isn't. It's not a bias. It's a sensible assessment of what's out there and the stuff it does on its own. If you get a satchel of these atoms together, and you just shake it up, huge molecules come out the other side. Give it an energy source, you can make amino acids just watching the thing. That's how sticky carbon is. So, now aliens wouldn't have to look like us, but there's a good reason to think that they would resemble us chemically. Now, they most certainly don't look like us. Most life on Earth doesn't look like us, and they have DNA in common with us. We have something like 20% identical DNA with yeast cells. Okay? Do we look like yeast? Do we look like worms? We're all part of the same family tree. We sort of look like other vertebrates because we have faces, and vertebrate is a face is a very vertebrate thing to have. Most life on Earth are not vertebrates. They don't have faces. Every alien movie, there's somebody walking out. Remember E.T.? He had 2 legs, arms, a shoulder. Okay, he had 3 fingers instead of 5. Oh, that's creative. Right? Had a head, 2 eyes, ears, nose, mouth. If you were a jellyfish, E.T. would be indistinguishable from human beings. Because that's all you would see. When you walk by a colony of jellyfish, are you judging the subtleties of, like, which the female is and which the male and who's... No, they're just jellyfish to you, all right? Because they're goopy and right? You're looking at broad characteristics, lumping them all together. So I had to deduce that, in Hollywood, they got to pay someone to wear the costume. And it's usually a human being they're paying to do that. We just did this. Okay, sorry. I don't know how it ended up there twice. You like the sound effect? Yes. All right. 2. The universe is of life. Here's that periodic table. You thought you'd never see one ever again after high school, did you? Some people like getting the shakes now. You should embrace this. This is what you will show aliens when they visit us, so they won't vaporize us on the spot. They can be proud of stuff we figured out about the universe. So there's the noble gases over on the right in purple. So there's carbon. I don't know if you can see carbon up there in column 14. Is 12.011. Look directly below it is silicon. So that's why people always try to swap silicon in with carbon, because they form similar bonds. They just have different strengths. And you don't break silicon bonds very easily, preventing further experiments from taking place. Carbon bonds are strong enough to get some action, but not so strong that they never experiment. So... there's a lot of cool stuff here. I mean, it's a whole other talk I could give. For example, this element was discovered shortly after the planet Uranus was identified, and so they named it after Uranus. And it's called uranium. That's how uranium got its name. And then the Neptune would later be discovered, and then they had an element waiting in line for that. You get neptunium. Then, 1930, a cosmic object called Pluto was discovered. In 1940, they isolate a new element, and they decide to name it after Pluto. So Uranus, Neptune, Pluto. So Pluto made its way onto the periodic table on false pretense. Just like take a Sharpie and just cross that off right there. The Pluto lovers out there. So, where do we get all these elements? They're forged in the centers of stars. Forged. The universe begins with hydrogen and helium. Out of the Big Bang, all evidence tells us that. And it's a smattering of lithium. And in the centers of stars, the cosmic crucible, that is the nucleus, undergoes thermonuclear fusion, the heating of nuclei to the point of bringing them together. And so the light elements are at the top, and they get heavier as you come down, and one by one, elements are systematically forged in the centers of stars. Stars that themselves ultimately die and explode, scattering these ingredients into the galaxy. Of what use would they be locked up in the centers of stars? Because we have those elements, and we're not in the center of a star. So we can move through this. This is a famous image from the Hubble telescope called the Pillars of Creation. That's if you hold it this way, but there's no up or down in space. I used to hold them sideways, but people got upset. Because the word mattered to them, not the idea. So these are gas clouds. They look like holes through glowing light, But in fact, these are dense gas clouds obscuring your view, and deep within them are regions of stars being born. These red dots are stars being born deep within these gas clouds. This image, it's called the Hubble Ultra Deep Field. And Hubble telescope took it. In this image, we're looking out from our own galaxy. And there are a couple of stars sitting on our nose, because it's our own galaxy. And one of them is sort of, you see this spiked thing at the bottom center here? That's a star sitting on our nose. A little to the right and up in the center, that's another spiked star that's also sitting on our nose. We're looking through a screen door through these stars and out to the rest of the universe, and every other thing on this image, every smudge of every size, is an entire galaxy, like the Milky Way. Each smudge, the smaller ones are just farther away. They're not actually littler, they are farther away. The large ones are nearby, relatively speaking. And this is a tiny patch of the universe on the sky. There are countless thousands of galaxies just in this image alone. And you contemplate this, and you say, you ask yourself, could we be alone in the universe? Probably not. Probably not. Look at the sheer scale of this operation here. You can say, are we alone in our galaxy? If you want to, okay, fine. But look at all the galaxies. Have we been visited by aliens? You know, I'm just disappointed that if we've been visited, they don't come to like Times Square, you know. They go to Farmer John's backyard or someplace. I just need better data than that. The eyewitness testimony is not cutting it. Bring me a dead alien, then we're good to go on that. Or better yet, a live alien. Then we can talk. Then we're cool. So you look at this image, and everything I just described, the manufacture of heavy elements in the cores of high-mass stars that explode and produce supernovas, scatter their enriched ingredients across their galaxy, that is unfolding in every one of these galaxies across the universe. And we are made of those ingredients. So, getting back to my letter from the University of Pennsylvania professor, who looks upon an image like this and feels small. I look upon an image like this and I feel large, because I know that the ingredients of life, the ingredients of the very planet on which we stand, are traceable to stars in pictures such as this. So that when I look up, it's not that we are here and the universe is there. Yes, we're in the universe, but more important than that is that the universe is in us. And it's that fact, discovered by 20th century astrophysics, that allows me to end with this slide, declaring, we are stardust. Thank you all for your attention. I think I went a little long, but I will take a few minutes for Q&A if with the host's permission. Yeah, a few questions. I do have permission. My host is in the front row, right here. I found her. The front row. Well, I'll repeat them so we can all hear them. Yes, sir, right there. Yes, loud. Okay, so the question was, how do I feel? First, will I do another Reddit AMA? AMA is Ask Me Anything. And I did a trilogy of these sessions, which is very intense. I sit there live, and people are just pumping questions, and I'm like typing them out with typos and everything. I'm just like, you know, that's what it is. That's what it feels like. And I was warmed by how strong the reaction was to the Ask Me Anything session. And people kind of knew what to ask. You don't ask, oh, Dr. Tyson, how far away is the sun? Well, Google it. Why are we wasting our time together on a Googleable question, right? So by and large, I think it was successful. I was just going to take a break. Maybe I'll do another one when we get closer to the Cosmos series when it comes out. But I do respect the Reddit audience. It can get manic a bit, but the audience is passionate about what they feel, and I will always support people with passion, however that expresses itself. And the second part of the question was, oh, how do I feel about it? I didn't plan it. You know, I was in a video talking about Isaac Newton, where Isaac Newton discovers calculus and the laws of optics and the laws of gravity, and then he turned 26. And so then I said, the guy's awesome, okay? Then that became look out, we have a badass over here. I never said that. I don't talk like that. So then that becomes a meme, and then, so I didn't try. It just is. Now, I happen to like tweeting. Okay, I tweet maybe 10 a week. I'm not a big tweeter. I'm an intermediate tweeter. And I like tweeting because these are thoughts I used to have anyway. I'm just walking down the street, and I say, if our blood were based on copper instead of iron, it would be green. If that's the case, then what color would the stoplight be? It'd have to be some color that would be scary. Right? So would that be green? But then green is the color of nature. So this is a thought I had. Well, I tweeted that. People said, mind blown. Oh my gosh. This is just thoughts I have. That's all. And so now, instead of them just evaporating from my brain, there's a place I can put them. And so, and I just make observations. I don't pontificate. Some people would say that my observations are pontifications, but really, if you look at them, I don't try to give opinions. You make your own opinions. I just offer perspectives, cosmic perspectives. I got another one. It was, we like to think of our self-importance, but did you know that in 1 linear centimeter of your lower colon lives and works more bacteria than human beings who have ever been born? So we think we're in charge, but the bacteria have a whole other outlook on this. In fact, the human is a darkened anaerobic vessel of fecal matter for its enjoyment. If you're bacteria. I just try to offer perspective. I tweeted that. People said, mind blown, and I've tweeted it a zillion times. So I participate in the internet, but it's not with any goal, fame goal. It just sort of turns out that way. And yes, the access to college age is very high. It is very high. I mean, I can't walk down the street anymore. I mean, I can, but I don't get far. And I went to Comic-Con, my first time ever. And I went to the San Diego one, the real Comic-Con. Okay? People are as crazy as you ever thought they were, okay? Now, I had a picture. There was a very attractive alien walking the sidewalk, okay? And so I thought I'd take a picture. Yes, it's a female alien. Trust me on this one, okay? This was a female alien. But beautifully done. So we took the picture, and then I tweeted the picture, and I said, an actual alien landed on Earth. Except no one noticed because she landed at Comic-Con. So this was my thought that I had. So I tweeted that. So at Comic-Con, I couldn't walk the aisles, and I was flattered by it, but more important, I was honored by that, because there were famous actors walking by me. Yet I had a bigger crowd than many of them, and I realized that the Comic-Con crowd, of course they cherish their actors, but at the end of the day, they know that there is none of this without the real science. And I was a source of that real science for them. And so I felt adversarial for my community of astrophysicists. I said, I will represent my community in this community and talk the talk. And so I was honored that they felt that my knowledge base was more important than a fame factor. And that felt very good to me. And so we must be doing the right thing somehow. And then I tweeted at the end of Comic-Con, because there's Geek Central there, right? But I felt very comfortable that it's smart people who enjoy fun, know how to have fun. And so I tweeted, and the geek shall inherit the earth. And so this was just a sort of a shout out to what might be a positive future for a country that is rapidly descending in the science literacy scale. A couple more questions. Yes, sir.
Could you talk a little bit about the hypothetical planet Tyche is supposed to be 4 times the size of Jupiter and 500 times further away than Neptune is from the sun?
Oh, you're concerned about a planet that might be out there in the outer solar system. Yeah, there could be planets out there. Their gravity is of no consequence to anything closer in. This is a planet hypothesized because they see the movement of Kuiper belt objects. This is the belt of cometary material, Pluto included. And it's way out there, and it does weird things, and we think there might be another object out there. So, sure, there could be. Yeah. I got no problems with that. Just keep it the hell out of the inner solar system, all right? We're good, like, wreak havoc. A couple more questions. Yes, right there. Yes.
What made you want to find Krypton?
What made me want to find Krypton? So I got a phone call from DC Comics, and they said, we want Superman to come observe Krypton from the Hayden Planetarium. Will you mind first having the Hayden Planetarium shown, captured in comic? And by the way, would you mind being shown? And this is like Superman, you gotta, it's Superman. If it were Elastic Man, no. Or Aquaman, no, I'm sorry, all right? But Superman, come on. So I said, of course, how am I not going to say yes to that? I said, by the way, what's he going to observe? He's going to see Krypton get destroyed. And I said, oh, so he got here ahead of the light beam, so it's not a relativistic the speed of light journey, it's a wormhole journey. If that's the case, and he's seeing it destroyed from what happened 27 years ago, maybe I can find you a star at the right distance. And what color is Superman's home star? It's red. So I found DC Comics a red star at 27 light years away. Bada bing! There it is. So I said, here. All right, and so why not make it a real star if it can be? Then I called the International Astronomical Union, the naming commission, and I said, here's a star you don't care about at all, but we can name it after the Superman home star, which is called Rayo. And they said, oh, I'm sorry, that could open up a problem for other. This is the same committee that botched the Pluto nomenclature, okay? I already have history with them. So I said, if you don't agree, then you will lose this battle in the court of public opinion, because we can all call that star by Superman's rightful home star name. And there's nothing the IAU can do about it. Right? I said that to their face. They said it. So it turned out to be more than what was originally imagined. And it was a fun story, and I got to meet Superman. So the press release came out, and they wanted me to put a quote in there about science literacy and how you can learn science from comics if they're scientifically accurate. I said, no, that's a boring quote. Put in this quote. This is the quote they used, right? I said, as a lifetime resident of Metropolis, the least I could do is help Superman find his home star and home planet, given how much he has done for us in this great city over all these years. So that was the quote they actually used. A couple more questions, and we gotta call it. How about in the upper deck? Yes, very back row, in the cheap seats up there. Did you get in late or something? Is that how you ended up in the back row? Oh, okay. If you say interesting things, one is never the judge of whether they are interesting to others. Okay, second question.
Who is the smartest person you've ever worked with?
A living person or dead person?
Hopefully live.
Okay. Smartest person. I would say, for one of my books, which is called Death by Black Hole, that's a collection of essays I've written for Natural History magazine over a decade. And there's a faculty member at Princeton where I was when I wrote most of these essays that became the book. And he was my sort of personal editor of everything I wrote. And he's from England, so he's like properly trained as a Brit. You know, they got words we don't even know we have, right? You ever hear an English person speak? It's just embarrassing to us to be American. So he's got vocabulary. He just knows everything about everything, and and it's humbling that he hung up empty red pens over his desk that had been spilled onto the edits of the essays I gave him to comment on, like notches on a gun. So I would go there and be completely humbled, but I would grow for having been thusly exposed. He just knew the most about the most things in a deep way, and I only aspire to that level of knowledge. What about Dad? Oh, Dad, Isaac Newton. If I would go back in time and like chill with somebody, it would so be Isaac Newton. Okay? I'd bring like my iPhone with me and I'd show it to him, and I'd say, check this out, you know? Me and Isaac would we'd be so happy. Ike, he'd be. Right there, yes. Yes.
Could I get your thoughts on time travel possibility concepts?
My thoughts on time travel. If you go fast enough, you could just go into the future. There's no issue there. That's just regular relativity. Okay. In fact, there's a Russian astronaut who has the record for how far he's moved into the future, and it's by about I forgot the exact number, like 1,000th of a second, something like that. So he'll die 1,000th of a second later than he might have otherwise kicked the bucket on that. So that's not the problem. Backwards time travel is a little more problematic. We know how to do it, but it requires a command of matter and energy that we can't even dream of having, because you have to open up wormholes in such a way and then take trajectories around them, loop trajectories, where you can come back to yourself before you had left. Okay? You have to watch out for this, because you don't want to accidentally prevent your parents from meeting each other. That would be bad. And in fact, all those people I have to kill, like the Terminator story, I gotta kill all you have to do is separate them. You don't have to kill anybody. Prevent them from meeting. Prevent their great-great-great-great-great-grandparents from meeting each other. And the entire line of people that came after them will not exist. There'll be some other combination of DNA making other people and not you. So if you go back in time, just watch it. Okay? A couple more, and then we gotta. How about in the back? Well, they didn't pay apparently. Okay. Right here, yes. Before you blow a gasket, yes. Oh, can I offer my perspective on the pros and cons of wearing shoes during a lecture? If I give a talk on a performance stage, as is this, I take off my shoes. Because I feel like it's a stage. So I don't want to be lugging shoes around, you know. I don't want anything between me and the sacred surface of a performance space. And so that's my answer. What's that? Oh, because then it's just not sanitary. Right? So that's why. If this were a lecture hall, I wouldn't have taken off my shoes.
Why?
Didn't I just explain? Was it not? What? I think there's something sort of artistically sacred about a performance stage.
I meant why in general.
Oh, why? So specifically why, apart from the performance stage, I'm more nimble in the absence of shoes. And I feel strongly that if you are teaching, you have much more than the words that come out of your mouth to do the teaching. And so my body is part of what I bring to bear on the lesson plan. So, yes, sir.
If you were a young scientist just starting out, would you think it would be better to do your research in Europe or America?
If I were a young scientist starting out, do I think it would be better to do my research in Europe or America? Trend lines all point to Europe. There's a whole other talk I didn't give about the future of science literacy, and the trend lines are all upwards in Western Europe. And a little slower in Asia, but those vectors are in the positive direction. And all of our vectors, all of them, are in a negative direction. Not only that, there are forces operating that want to change the science curriculum to be something that's not science. So that would take out the kneecaps of a system that's trying to at least create a generation of scientifically literate people. So it looks bad. My hope is that when the Cosmos series comes out, that it creates an imperative, a national imperative. It will have all the marketing that it needs to have because it will be airing on Fox. People said, Fox? But they got a bunch of science nitwits on Fox. That's what. And I said, that's why it belongs on Fox. Let's shut them up like that, okay? So the last thing we need to do is preach to the choir. So the goal is to have the maximal audience it can and convey the significance and importance of what it is to be scientifically literate in a free democratic society. So I'm hoping to alter this downward spiral in which we're embedded. How are we going here? Right here, yes. Yes?
Can we hear the story from your mouth of the night sky on the Titanic and how you got James Cameron to fix it?
Oh, can you hear the story about the night sky over the Titanic? Because I just pissed him off. Yeah. I'll tell you quickly, but it's on YouTube, so that's why you don't need. Well, whose mouth is it on YouTube when I'm speaking? Is it a doppelganger? What? Who? That was me on YouTube, in case you didn't know. So in Titanic, the ship sinks. Hope I didn't spoil the end of that movie for anybody. This Kate Winslet on the plank, looking up, and then the camera goes to her point of view, and she sees the night sky over the sunken Titanic, and it is the wrong night sky. Not only is it the wrong sky, the left side of the sky is a mirror reflection of the right side of the sky. So it was lazy on top of being wrong. I wrote a letter to Cameron. I said, you know, look, you told us how accurate your movie was because you went down to the Titanic in a submersible and you took photographs of the staterooms and the china patterns and the wall sconces, and you reproduced that for your movie with such accuracy that you boasted this and the release of your film, and you can't get the sky right. We know the longitude, the latitude, the day, the time, what phase the moon was in. We know everything there was about the night sky that night, and you got it wrong. What are you going to say about that? He said, actually that happened in post-production, and so he didn't oversee that. Now, I wanted him to grovel at my feet for forgiveness, but that's not what he did. And so I was not happy with that reply. But it was a reply nonetheless. Several years later, I run into him again. I mention it again. But no, to third time, he comes to New York to get an award from Wired magazine, like Explorer of the Year. Where do they hold their party? At the Hayden Planetarium. Tonight is my space. So I then say, all right. Oh, no. So I got extended a courtesy invitation to join them for dinner after the awards. So it's 8 people for dinner. I'm there. He's there across the way. The wine is pouring. And I can't leave well enough alone, right? So I said, Jim. Because he's Jim now, because I'm fed up. Jim. How could you not pay attention? Why did you do this? And he said, last I checked, worldwide, Titanic has grossed $1.3 billion. Imagine how much more it would have grossed had I gotten the sky correct. Well, that shut me up, right? So tail goes between the legs, and I walk away, and that was the end of it. Until a month later, somebody calls me up. I forgot his name. Johnny Smith calls me up. He said, Dr. Tyson? I said, yes. And he said, I work post-production for Jim Cameron. We're producing a 10-year director's cut anniversary edition, which has extra footage, and he tells me you have a sky he can use. So I said, yes! Don't put that on the internet. So now, it turns out they never did release a 10-year anniversary director's cut. But he remembered that conversation. And when the 3D release at the 100th anniversary of the actual sinking came up, that early conversation became the present conversation. And he remembered it and decided to reshoot the scene with Kate Winslet, putting the correct sky that I had handed him into that. And it's the only part of that movie that they reshot. And so Cameron came through in the end. He could be pompous, but at the end he's got integrity of his trade, and as an artist and as a film producer and as someone who actually cares about science. And so the press got it a little wrong. They assumed that I was nipping at his heels for the 3D release, but I nipped at his heels 10 years ago. And then we just transplant that into the present. And he said, which they didn't quote in the respectable newswires, but in the ones that didn't care, his actual quote was, yeah, I had to get that son of a bitch off my hands. But it was an affectionate son of a bitch. You can say that in an affectionate way, I keep telling myself. Okay, 2 questions, and then we got to call it a wrap. There's someone right behind you. Yes?
So, I don't know if you've been hearing what's happening in the state of Tennessee, where they're encouraging teachers to teach the weaknesses of things, and strengths and weaknesses of evolution and global warming and other such things. What do you think that we as citizens of Tennessee can do about this, and what are your thoughts to getting out of this?
Okay, so the question is, they want to teach the strengths and weaknesses of global warming and evolution and other clearly politically, religiously motivated topics. All right, I don't hear them saying, let's teach the strengths and weaknesses of gravity, right? Or Because there's a frontier of gravity that we're still exploring. They didn't say that. Okay? They cite the ones that exist on the political, cultural, and religious landscape. So, it's not a problem to teach strengths and weaknesses if it's an actual strength or weakness that goes on the frontier of the science. If it's an actual strength and weakness, then that's what goes on in the world of science. At the level of elementary school, junior high school, and high school, the stuff that's taught is, no, scientists are not debating the evolution that's in your evolution of your biology book. And so what the public has been confused about, and part of it is because there are forces, strong, organized forces. Another part is the journalist. The journalistic ethos is, if you give a point of view, you now have to go find someone who gives the opposite point of view, and then they're being fair. Yeah, but if 95% of scientists find a consensus of experiment that says one thing, you're going to run to the 5%ers and then give them 50% of the time, so that the public thinks that it's a 50-50 toss-up about what is agreed upon and what is not. So there's a delusional force operating on what the public thinks is going on the frontier of research. And so that's a problem. It's a problem, and it's the beginning of the end of America. I mean, I'm sorry to say that, but once you take out the foundation of what we know and how science works, and put some kind of suspicious doubt where there is none, the people are not understanding what science is and how it works, and what we do know, and the real stuff that we don't know. They're not actually learning that. And so Tennessee will not be the source of the next generation of scientists and engineers, if that spreads throughout the school system. Now, we live in a free country, and the government, the federal government, does not have a say in local education because it does not appear in the Constitution. Anything that does not appear in the Constitution is what? It's the purview of the states. That's what we kind of all bought into as American citizens. So legally, the government, yes, the National Science Foundation can put up a lesson plan and say, we recommend this, but you don't have to follow it. You can have a school board vote it out. That's kind of what it is to be in America. So what I think might be the strongest force is when companies, high-tech companies, think about moving into a county, and they find out that the school board is teaching things that is not science, then they choose to move somewhere else. And then that state loses the jobs. That county regresses economically. That, to me, would be the strongest force to operate on the future of America as a technologically proficient country. Without it, we'll just fade. I mean, these are choices we make in a free society. I will never hit someone. I will not tell the school board how to vote. I will tell you the consequences of voting that way.